Live today. Thank you very much for making time for those watching the recording. You missed a great webinar, but hopefully you can catch up. Today we've got something a little bit different. We're going to be co-presenting. We're going to be talking about using Bitnami Stacksmith with Spotinst to take an existing application and move it to the cloud in a pretty exciting way. So very excited to be joined by a co-presenter today. Over the next 45 minutes or so, we're going to show you how to take an existing Java application, package it using Stacksmith, and use the Spotinst Elastigroup solution to run that application on the cloud. I wanted to take a moment to introduce myself. So my name's Simon Bennett. I'm responsible for products here at Bitnami. I'm based in San Francisco. My co-presenter is Yuval. Maybe Yuval, you could introduce yourself.
Yes. Hey, everyone. So my name is Yuval. I'm leading the solution architecture department in Spotinst, and I'm located in New York City.
Excellent. Thanks for joining us today. So just in terms of the agenda today, we wanted to spend a few minutes introducing the respective solutions. So I'm going to spend a few minutes talking about Bitnami and particularly our Stacksmith solution. Yuval is going to introduce Spotinst and the Elastigroup Managed Container Service, which is a pretty exciting service. When Yuval showed it to me a couple of weeks ago, I was really excited to see what they've built. So we're going to spend 10-15 minutes on sort of introductions and some key concepts. Where we want to spend most of our time today is really on a series of demos, which is taking that application source code, compiling it, building it into a deployable artifact, in this case a Helm chart, and then using that to deploy the application into a production environment. So both Yuval and I are pretty keen on showing you how and being a little bit hands-on. At the end, we're going to switch into a live Q&A session. So there is a chat feature inside the conferencing tool here. It's down at the bottom of your screen. Please feel free to drop questions and comments into there. We've got plenty of time at the end of the session to dig into those. Both Yuval and I are very interested in answering those questions, starting a little bit of a dialogue. Miranda, who's running logistics for us here today, will be sort of emceeing and triaging those questions for us. Hopefully we'll be finished within 45 minutes or so. A little bit of variability depending on how many questions we get. So that's the overall agenda. I'm going to go ahead and dive in. So Bitnami is primarily known as the leader for packaging applications on any platform. Most people get to know about Bitnami from our cloud images. So we partner with the likes of Microsoft Azure, Amazon Web Services, Oracle, Google Cloud, VMware, a number of other large public cloud providers. And we offer a curated collection of applications, infrastructure components, runtimes, and other interesting things that can be run on their clouds. They're distributed as VMs, they're distributed as containers, as Helm charts, and some other non-cloud formats. Bitnami has actually a range of products. So I just described our sort of app catalog offering, which most people are familiar with, and sort of that's where they come across the Bitnami name for the first time. The product we're going to be focusing on today is Bitnami Stacksmith. So Stacksmith is a managed service we launched a little earlier in the year, which is targeted at a different set of applications. Stacksmith is really targeted at companies who are looking to build new applications for their companies and deploy those onto different cloud platforms. Stacksmith is kind of built on top of a lot of the automation that Bitnami built internally to provide our app catalog. So Stacksmith is a way that you can make use of the automation that we built to do things like build cloud images for different platforms, build containers. A lot of the work that we've done as early contributors to the Helm project and Kubernetes in general it's sort of been baked into that Stacksmith experience. There are some other areas that Bitnami works in the Kubernetes community. Things like kubeconfig, sealed secrets, kubeless have been done in partnership with some of the key companies in that space. Here's a little bit more of a deep dive into Stacksmith. So Stacksmith is a solution that sits usually in your software delivery pipeline between sort of CI and your software delivery tools, and gives you a way to automate the packaging of those applications so that they can be deployed on any platform. Stacksmith today is primarily used for targeting AWS and Microsoft Azure. There'll be more cloud platforms to come in the future. So one of the unique capabilities of Stacksmith is you're able to target either VM or container-based deployments with the same application and the same set of assets. Stacksmith is also able to make use of any native managed services on each of those cloud platforms. So very common for folks to want to connect to a managed SQL database, an Aurora database. Maybe you make use of cloud native load balancing, whether that's with an existing application or an application that they're developing to be sort of cloud first. The other key benefit of adopting Stacksmith is because it's built on top of a lot of the automation and tooling that Bitnami built internally. Once Stacksmith has packaged an application, it continuously monitors the artifacts in that application to make sure you're aware when they need to be updated. In particular, in the open source ecosystem, lots and lots of changes, new versions, bug fixes coming along all the time, and Stacksmith makes it ridiculously easy to stay on top of those by providing proactive notification when things are out of date and a one-click rebuild of all of your application artifacts. I just wanted to give a high-level overview. We're going to be using Stacksmith sort of in the first demo here, just to give you a conceptual flow of what Stacksmith is for. There's lots of different ways that you can create an application to run on a cloud platform. Obviously, if it's new code, you can build it in a cloud native way. You might choose to use something like a 12-factor principles or maybe a loosely coupled architecture. Stacksmith is also interesting for folks who have existing applications. We like to describe Stacksmith for existing applications as kind of a re-platforming approach. Instead of just picking up a VM that's maybe running in your data center and re-hosting it onto the cloud, Stacksmith allows you to re-platform that application. So maybe take your existing code, your existing dependencies, and move it into the cloud in a way that it can make use of things like managed databases, native monitoring, and all of the other good things on that cloud platform. We think replatforming is a good approach for applications because it allows you to take the existing infrastructure, the existing tools that you have, and use them in a cloud context. But you can then add new features and capabilities onto that application using things like serverless solutions. You might choose to use kubeless from Bitnami, or maybe one of the native tools, Google Cloud Functions, Lambda, something like that. We also believe that replatforming is significantly faster and cheaper than rewriting an application or re-architecting it for the cloud. And hopefully the demo today will show you how quickly that replatforming can happen. I think I talked about each of these use cases in the introduction here. Certainly cloud migration and application delivery. The bottom two here we're going to just touch on very, very briefly. We've started to see folks use Stacksmith in combination with kubeapps, which is one of the other solutions in the Bitnami catalog, to provide sort of a self-service application library for their internal teams. So just as you can go to the AWS marketplace today, look for some pre-canned solutions that solve particular problems, we're starting to see companies and teams within those companies publishing applications and solutions into sort of the internal equivalent of a marketplace for use by their colleagues and the other folks that they're working with. Not going to get too deeply into that today, but I'm happy to take questions around it or schedule a follow-on call. Maybe we can jump into a quick introduction to Spotinst.
Yes, please. So I'll share my screen, just a second. Great. All right, so hey, our main goal here at Spotinst is really help our client reduce your cloud compute cost. We're doing it with a few different ways. The main technique is to utilize the cloud provider's excess capacity. I'll get to it in a second. A really quick overview of our company. We founded around 3 years ago. I raised some money, mostly from Intel Capital. We are over 80 employees today. I probably lost track this week. We're probably 90. Have hundreds of clients all around the world and offices, New York, San Francisco, London, and Tel Aviv. Few words about cloud provider excess capacity. So it's come in a few different shapes and forms. In the case of AWS, we're speaking about Spot instances. Google Cloud provide preemptible VM, and Microsoft Azure provide low priority VM. Those instances offered with a great discount, anywhere between 70 and 90% on comparison to the on-demand instances. They have the same names, they have the same performance. The only challenges while using those instances, the cloud provider can take them away from you in any given moment in time with a really, really short notification. So really, we really at Spotinst found a technique to allow you run any type of workload, stateless application, stateful application, production application on top of those instances. The way we're doing so, we develop a special prediction algorithm by combining really past analytic data and some machine learning. We know to predict when Amazon or any other cloud provider is about to take those instances from you. And we know to do all kind of operation ahead of time in order to prevent any degradation. So the easiest way to understand probably, let's think about a few instances behind the load balancer, managed by Spotinst with Spot instances. Spotinst determine that one of those instances is about to get interrupted by the cloud provider. Then what we're doing is launch another instance, join it to the load balancer, make sure it's healthy, and only then gracefully terminating the instance that's about to get interrupted. So really basically provide you with the same experience as you'll get with on-demand instances, the same SLA and the same availability, while enjoying the deep discounts of Spot instances. Few words about Elastigroup in general. Elastigroup is our cluster management software. It's very, very similar to Autoscaling Group in AWS, if you're familiar with, but we like to call it Autoscaling Group on steroids because it has some additional nice features that really allow us to run production environments on Spot. First, we can really easily blend on-demand instances, reserved instances, and Spot instances on the same group. You can really control the amount of each type, and you can control the conversion. In addition, you can choose many different instance family and sizes. So you're not buying to a specific instance type, family, and size. We did it originally in order to support multiple Spot markets inside your Elastigroup. So important to understand that the Spot market in AWS is built off of the combination between availability zone and an instance type. And by allowing our group to support multiple instance types and families and multiple AZs, we can increase the Spot market diversity in the group and make the best decision each and every time we need to launch an instance for you. So this is another very important feature of Elastigroup. A third important feature that connecting with the MCS feature, which I'll get to in a second, that Elastigroup can natively integrate with many, many different products. So starting from Autoscaling Group, load balancers, OpsWorks, CodeDeploy, Chef, Ansible, and going to container orchestration platforms such as ECS, Nomad, Docker Swarm, and of course, Kubernetes. Elastigroup MCS is our special Elastigroup that we design for container orchestration platform. In addition to all the great benefit I just mentioned that is general for Elastigroup, in the case of MCS, we know to deeply integrate with the container orchestration platform. In case we need to replace instance because of a spot interruption, for example, we know to drain all the container from the soon to get interrupted node, and we know to schedule the containers equally across the nodes in the cluster, join new nodes to the cluster, and in that way really handling spot interruption without causing any interruption or downtime for your Kubernetes cluster or to any of the application running on top of it. Another really interesting feature we developed for Elastigroup MCS. So as I mentioned earlier, and I'll show it later in the demo as well, we know to choose many different instance family and sizes inside Elastigroup, and we did it for spot market diversity. We thought a lot with our clients how we can have some additional benefits from this diversity of instance family and sizes, and we decided to develop an autoscaler for container orchestration platform, ECS and Kubernetes, as well as Docker Swarms and Nomad. Our autoscaler is really special because it's not scaling your Kubernetes infrastructure up and down based on threshold, based on CPU, memory, or requests per second, as a normal autoscaler would work. We're really looking into the container resource requirements and know to launch instances, extend your infrastructure in order to meet these requirements. And this is lead to a really, really tightly fit infrastructure that hold the containers in the most, I would say, the most efficient way. Few notes about our autoscaler: you don't need to define any scaling policies because we're not scaling based on policy or threshold. We're actually scaling based on the container resources requirement. We're looking into the event inside your cluster. We're seeing how much resources each container, each pod require, as I mentioned earlier. And we know to perform a very graceful scale down for you as well. So determine underutilized instances in Kubernetes is relatively easy, but perform a scale down without harming the actual availability of your pods is a bit more complicated. Before performing scale down, we look if your cluster can handle all the currently running containers from the node we're about to scale down, and then safely drain this node if we can do so and scale it down. So a lot of nice advantages. It will all come together in the demo. Please, Simon.
Great, thank you for the overview there. Well, let me just reshare my screen. Here we go. Okay, so the demo here is really divided into two parts. The first part we're going to do here is take our existing application and package it for deployment on Kubernetes using Stacksmith. So give me just a moment to reorganize my screen here. There we go. So let's start with the application. So our application for this demo is a pre-existing Java application. There's really nothing special about it. It's actually a very simple application, but it was written using the Spring Boot framework. It's just a simple customer list application. Sort of the key point of this demo is we're going to take some existing code and we're going to deploy it onto the cloud without actually changing the code. So first step we're going to do here is using our Maven build, go package it. So what this is going to do, oh, I just rebuilt it, so there were no changes. There we go, should happen pretty quickly. Is we've taken the source code for our application and packaged it into a WAR file. So very, very standard. If you were a Java developer, you might use an IDE like this to go make some code changes. You might build it locally as I did, or you might have an existing CI pipeline, something like Jenkins set up to do these steps for you. Once you have the application contained in the WAR file, you probably want to deploy it. So historically, you might use a Java application server, a WebSphere or a WebLogic to do that. Certainly in a cloud context, we see people using some of the smaller Java runtimes. For the demo today, we're going to be using the open source Java Tomcat application server, and then packaging it so that it can be deployed onto a Kubernetes platform. The way we're going to do that is using Stacksmith. Don't need to look at my email right now. There we go. This is Stacksmith. So Stacksmith is offered as a managed service. It's an annual subscription operated by Bitnami. And by way of setup before the demo, I logged into Stacksmith and connected Stacksmith with my AWS account. This is a key part of using Stacksmith because all of the operations that Stacksmith does to package the application happen within the context of the user's cloud account. So you don't have to trust Bitnami to store your application or your script securely. All of the things that you do through the Stacksmith web interface or the API that sits behind it happen within the context of your cloud account. So all of the applications that we build get published into buckets that you control that are private, into the Elastic Container Registry, which is private to you. This is very different from Bitnami's app catalog, but very, very important for people who are looking to use Stacksmith to package their own applications. In order to package an application, I have to tell Stacksmith a little bit about what that application is and where to find it. So I'm just going to fill in this form here. I'm going to give it a name and a version. Really, the first important choice I need to make is pick the template that most closely matches the application architecture that I'm going to deploy. So Stacksmith comes with a number of pre-configured templates for common scenarios, things like Java applications, Node. A generic application is really any application that runs on top of Linux. .NET Core. The template I'm going to be using today is this horizontally scaled Tomcat application with MySQL. So what that is I took our out-of-the-box sort of best practice Tomcat application and I tweaked it a little bit for the purposes of the demo. The way that I tweaked it is I made sure that the application will be deployed, 6 copies of the application will be deployed, so 6 replicas of our Java code. And I also made sure that when this application is deployed, a load balancer will also get deployed so that we can access the application itself. So that's what's in the template I picked there. I'm going to stick with the default CentOS as our base operating system. The next big decision I'm going to make here is which target platforms do I want to build this application for. For the demo today, we're focused exclusively on AWS, so I can pick building AMIs and CloudFormation templates, or I can pick Docker container images and Helm charts. So I'm just going to do the latter today since Kubernetes is our target platform. If I wanted to do a VM-based deployment as well, I can actually pick both, and Stacksmith will build both of them for me from the same set of artifacts. 2 more pieces of information that Stacksmith needs. Obviously, it needs the application that we're going to package itself. So that's the application code. The other thing it needs is a very, very small boot script. So the purpose of a boot script is to configure the application to be able to talk to its database. So this is a toy demo application, but it still needs to be able to store information into a database. So all this script does is very, very simple, just sets the appropriate data source names. because Stacksmith exposes this kind of environment information in a consistent way, regardless of which platforms we're building for. I can typically write one boot script regardless of the platforms that I want to target, which could be different formats on the same cloud, or it could be multiple clouds. The other thing I could provide that's actually not needed for this application is I could provide a build customization script. So this performs a similar role to sort of a Docker base image. If I wanted to layer in particular libraries, if I wanted to add a monitoring agent, if I wanted to somehow lock down or harden this configuration in a particular way, I can do that right here. I'm going to hit create. What that's going to do is schedule a job to go package our application. That process takes between 5 and 15 minutes, depending on which targets you build for. So typically building a VMs are much bigger than container images, takes a little bit longer. For something like Kubernetes, building container images and Helm charts, it's usually in the region of 5 to 6 minutes. While that's going on, I get a set of logs sort of streaming into my console here. All of the logs that are produced by Stacksmith in packaging the application all get persisted into your account. So this creates a nice audit trail of who built which application, who packaged it, in what account. I'm just going to jump over to an application. This is one that I built yesterday, so you have an idea of what you can see for a built application. So all of the packaging logs have been persisted here, but Stacksmith now knows all of the packages that were pulled in to support that application. So as an app packager or as an app developer, I kind of got a PaaS-like experience. I just gave some high-level information about what my application needed. But Stacksmith has now gone in and got a full inventory of all of the libraries, all of the dependent packages and their dependencies that went into supporting this application. As you can see, there's 24 pages of different things that got pulled in there. This image is up to date and is being scanned by Stacksmith, so we know the packages in this application are up to date. If I take an example which was built a little bit longer ago, you can see Stacksmith now knows that there's updates to this version of the application and will actually tell me which packages need to be updated. So when I shipped this application out, I included a version of the OpenJDK runtime, which is actually out of date now. So Stacksmith doesn't just tell you that that application is out of date, it also gives you a way to update the image. Very, very simply, that's the purpose of this repackage button here. I'm not going to show that in this demo today, but I'm happy to answer questions about it. Looks like this build is just going to take a couple more seconds here. While that's going on, I'm just going to jump into settings here briefly. I mentioned that Stacksmith ships with a number of different templates, and I mentioned that I'd customized this built-in template. This is a new piece of UI that we just landed this week that allows me to upload new versions of those templates. So these are the steps that I went through before. I can build on the existing AWS CloudFormation-based template. If I wanted to, say, upgrade the auto-scaling group in there to the the Spotinst equivalent and get their advanced functionality, I can do that by customizing the template. Similarly, for Kubernetes on our target platform, I can customize the Helm chart there. Okay, that's going to take another minute or two to finish. I'm going to jump into the one that was already pre-built. So this is the Spring application. Once Stacksmith has done its thing, pulled in all those base images, rendered me a chart, it will give me a downloadable Helm chart here. So this is a completely vanilla Helm chart based on the application that I provided up front. It points to a fresh container image, which was built in our Elastic Container Registry. If I wanted to, I could offer that as part of a self-service experience. So let me just swap over here, start this one up. So this is not part of Stacksmith. This is Bitnami's KubeApps solution, which is an in-cluster dashboard solution. I could offer that on a self-service basis within the application using something like KubeApps here. If you're using something like Artifactory as a chart repository, you could also use that to store the built artifacts that Stacksmith has provided. That's a quick overview of sort of the key features of Stacksmith when targeting Kubernetes. Let's hand things over to Yuval. He'll show us how we're going to deploy that built Helm chart onto Kubernetes.
Thank you, Simon. Right. So let's start from a short overview of Spotinst platform. So Spotinst is a SaaS platform. It's connecting to your AWS or cloud provider account, and it's creating resources inside your account. So nothing is running on our side. You have complete control and visibility to your resources, but we're just helping you making better decisions and creating cheaper instances for you. So this is an example of a console for a live account. You can see here, we're managing 44 Spot instances. For the last 30 days, by the way, those 44 instances would cost more than $67,000 if they were run on-demand instances. And by running them on Spot, you can see that we're paying a little bit over $20,000. The saving is 70%. We saved during the last 30 days more than $47,000. So a really nice saving over here. Elastigroup, as I mentioned earlier, is our cluster management software. Here we have a list of the Elastigroup. Each one of those lists can really represent, in Kubernetes case, nodes for your Kubernetes cluster. So each line can represent a Kubernetes cluster. We'll go into one of those groups. You can see that in this specific group, we have 41 nodes. So relatively large Kubernetes installment, medium size, I would say. Again, we can see the potential cost this month versus the actual cost that we pay for the Spot instances. You can see some really interesting details regarding the Kubernetes cluster itself. So you can see the version, amount of registered node and running pods. You can see here how many pods we have over time in our Kubernetes cluster. And we can see the different deployments. So we can see deployments, and inside the deployments, we can see the different pods that are running inside the deployment. So a really nice overview over here. I want to show you the configuration wizard of this group to get a better understanding of how Elastigroup is built. I'll do it really quick. In capacity here, we'll choose the amount of instances we want to create once we're creating this Elastigroup. Minimum and maximum are the borders for any scaling policies or autoscaler for Kubernetes we might have in this group. Here in advanced, we can choose the blend between Spot and on-demand. So by default, we're trying to aim for 100% Spot because we can really handle Spot interruption and we can run Spot instances in production. But if for some reason you want to have a certain percentage or a certain count of on-demand inside your group, you can really easily configure it here. By checking utilize reserved instances, by the way, if we see you have any vacant RIs in your account, we'll first utilize those RIs because you already invested the money, and why not saving a little bit more? So before launching even Spot instances, we'll launch reserved instances. Fallback to on-demand is a really important feature. In the worst case scenario, the Spot market is really bad, Spot instances is really expensive, the worst thing is going to happen, we'll just create an on-demand for you. This is how we assure you the SLA of your group and the availability of your application. Here we're controlling the compute resources inside our Elastigroup. So first, of course, we're choosing the VPC. We want to launch their instances in. As I mentioned earlier, Spot market is built from availability zone and instance type. So we encourage you to choose as many of those as your application supports in order to increase the diversity of the group. Here we can choose 3 availability zones. Here we can see all the different instance types that we can run as Spot. So a wide variety of instances were chosen here. This is an actual glimpse into Spotint's prediction algorithm. So you can see we're providing a score for each one of the markets. So this is you can really see how we are choosing the right instances for you based on availability and price. And this is updated all the time behind the scenes, but you can see how we make these decisions. In addition, as I mentioned, in the case of Kubernetes, we're not only choosing based on the best market, we're also creating an instance that will right fit it for your pod and container resources requirement. So if you don't have any more resources, let's say in your Kubernetes cluster, and you try to launch a very small application, we're probably going to go with the smallest instance possible to extra large in this case. But if you try to deploy many pods or really large pods, we're probably going to go with the largest instances here. Here in integration, we configured the Kubernetes integration or any other integration. As I said, Elastigroup can natively integrate with many different products. Kubernetes is one of them. It's very, very easy to define this group as a Kubernetes group. All we need to do is install a pod inside the Kubernetes cluster, link with unique identifier the pod to this specific Elastigroup, and then define whether we want auto-scaling enable or not enable on this group. And now I'll go to the Kubernetes cluster I created for this demo. So Simon built an application for us using Stacksmith. I happen to have this application, and I really want to deploy it on my Kubernetes cluster. I have a relatively small cluster. Currently, it's one instance. The application, we tweak it to consume a bit more resources, so one node probably not going to be enough. But let's see how Kubernetes, Spotinst Kubernetes Autoscaler, which is enabled in this group, will help me deploy this application without really thinking about what type of infrastructure I need for this application. So let's just make sure. I'll have a lot of typos here. I'm sorry about it. So we can see this one instance in the group here. It's the same Kubernetes cluster as I showed you in the Elastigroup. Here's the Spring app Simon just built for us. If I'll go ahead and install this application, great. Now we can see that a few pods being created. MySQL is the first one. A few more pods. Let's give the MySQL a moment to init. You can see here that few of the pods are pending, so let's see why. Let's take one of those. Insufficient CPU. So right now, it doesn't really matter if my Kubernetes cluster, let's say, have one instance, and I cannot schedule this specific pod because it requires a certain amount of CPU. You can see it here. And usually, I would wait for a CPU threshold to my node to hit certain CPU threshold in order to perform an auto-scaling operation in my infrastructure. In the case of Spotinst, let's see what's going on here. You can look into the log and see that Spotinst controller, that look is not interesting here. We provision additional instance. Let's see this instance. Great. So because we've seen inside our Kubernetes cluster that we cannot launch those instances, Spotinst Autoscaler determine what will be the best instance type to launch. So in this specific group, I can launch few different instance types from few different sizes. So you see all the way from large to 4 extra large. But because the compute resource requirements of those specific pods wasn't as high as required for 4 extra large or 2 extra large instances, Spotinst Elastigroup chose to launch for me a smaller instance from C4 large. And let's see the actual instance. I already have it in the cluster, fantastic. And I see the containers now, all the containers that were pending right now being created. We'll give them a second to get created. So what's really nice, I don't really need to think about my infrastructure anymore. I can build application any way I'd like using Stacksmith, for example, then provide my application to the cluster operation team or deploy them myself, and Spotinst autoscaler will make sure I have enough infrastructure to run those specific applications. Now we can see we have all the pods running, and we can actually test the application if we're really brave here.
Got my fingers crossed, Yuval.
Yeah, let's see if I'll be able to write. So we got his Spotinst Bitnami Spring app. We got an external IP for the ELB. Great. Oh, and we have the application running. So that was really easy. We built an application using Bitnami Stacksmith. We deployed to Kubernetes. And using Spotinst autoscaler, we actually provide with the right infrastructure for this specific application. And I think we really had a successful use case right here. What do you think, Simon?
Excellent job, Yuval. That was great. You make that look super easy.
Thank you.
Cool. We're about roughly on time. I just wanted to wrap things up briefly, and then we can sort of jump into the Q&A here. I'm very interested to hear what folks want to hear more about. So, in closing, Stacksmith is a way to meet your dev team where they are with applications they already have or that they're developing, with a way for them to target the cloud very quickly. You saw how you can use Stacksmith with very little information about an application and package it up to be deployed on any platform. And Yuval's great demo showed how we can take that deployable artifact and deploy it onto Kubernetes with very low cost, both in dollars and in operational effort. If you're interested in taking a closer look at Stacksmith, we're happy to help folks get onboarded and get their first application packaged. Yuval, could you give a little bit of an overview for folks who are interested in taking a deeper look at the Spotinst family?
Yeah, of course. So we offer 14 days completely free trial. We more than encourage you to go ahead to this console, sign up, and try our product. It's really, really simple. You don't need to change anything in your current workflow, and you can right away enjoy the benefit of Spot instances in any of your environments.
Great, thank you very much. We wanted to jump into Q&A now. So if you joined late, at the bottom of the screen, there's a button you can press. Please submit your questions there. Miranda's going to be collecting those up and making sure that we get to as many of them as possible. Thank you very much, Yuval. It was great to see that demo in action. I really enjoyed it. It's a fantastic platform the team has built there.
Thank you.
Great. Miranda, do you have some questions coming in?
Yeah, we did. So one of them is actually for the Spotinst team. It's, can I build a reliable Kubernetes cluster using Spot instances exclusively?
Yes, so definitely. As I mentioned, we really, in Spotinst, perfected the usage of Spot instances for any environment, including production environment. So to be honest, most of our clients running production workload on top of Spotinst, and they're doing so with 100% Spot instances. So we really provide with the SLA and the availability needed for a production environment with Spot instances.
And then another one, actually, Simon, this one is for Stacksmith. Can you provide clarification on where the assets that Stacksmith creates get stored?
Yeah, so when you onboard into Stacksmith, whether it's for AWS or Azure, you provide us with a limited set of permissions which allow us to write into particular buckets and provide and execute certain build actions. So things like building AMIs. All of those activities happen within your cloud account. And they're stored in a S3 bucket if you're on AWS, or if you're, say, building container images on Azure, they would be stored in the Azure Container Registry within your account. So Stacksmith provides sort of the control plane and the UI and the API, but all of the things that it builds, including your application artifacts, your armies, your charts, are all published into storage buckets that happen within your account. For folks who are evaluating Stacksmith, we're happy to give you a sandbox account to work in, which is controlled by Bitnami, but that's purely for evaluation purposes. Sometimes there's a level of kind of sign-off and approvals that's needed to get access to a corporate AWS account. So we're happy to lend folks an account if they just want to trial Stacksmith, run a few applications through it, try some deployments, kind of like the ones we did with their own application.
Great, yeah, that actually answers probably the next question that I was going to ask, because that would be then the way that someone could trial Stacksmith if they didn't have an AWS or Azure cloud account, correct?
Yeah, that's right. We prefer it if folks didn't, start mining Bitcoins in there, but we're happy to lend folks an account for as part of their evaluation.
Great. Okay, and then this is one of the last Spotinst ones. How does Spotinst maintain the Kubernetes cluster availability when it replaces a Spot instance?
So we really doing the process in a graceful manner. So let's say we have few instances in a Kubernetes cluster, and we determine one of those instances is about to be taken away by a Spot interruption. What we're doing is actually creating an additional instance ahead of time before we're performing any other operation. Make sure this instance, the new instance, is healthy and inside the Kubernetes cluster. Only then stop scheduling new pods to the soon-to-be interrupted node, draining all the pods from this node, making sure all the pods safely evicted from the soon-to-be interrupted node, and only then safely terminate it once all our application is up and running on different nodes.
Got it. Okay, great. Thank you for that clarification. And we then also had another question come in. Is Spotinst the solution which is built on Kubernetes, such as Microsoft has AKS and Amazon has EKS? Is this a similar solution?
So Spotinst is a solution that can work with any of those specified solution. We really help you managing the underlying infrastructure layer of your Kubernetes cluster. It doesn't matter if the Kubernetes cluster is native Kubernetes, whether it's built with kops, utilizing EKS, AKS, GKE, or any of those 3 letters Kubernetes cluster. Really know to drive a better infrastructure scaling and cheaper and more efficient nodes for those Kubernetes cluster. So it's not replacing any of those, it's working together with it.
Great, yeah, and I think that shows a lot about kind of the marriage between Stacksmith and then using Spotinst actually, because the Stacksmith, you can obviously put any of those templates or formats that you need, and you can get that output through Stacksmith and then use Spotinst to manage them, as you mentioned. One of the last, there's 2 last questions. What's the average savings seen for the Kubernetes cluster of Spotinst?
So it's really depend on the instance types and the region. The average saving we're seeing for Spot instances is around 80%. But because we're also utilizing the autoscaler for Kubernetes and choosing the right instance sizes and really right fitting the Kubernetes cluster size, So we're seeing this 80% saving in addition for some additional efficiency in the cluster. So instead of having, let's say, 10 instances, you'll have 7 instances. So we can push the saving on a comparison to a classic Kubernetes cluster to even 90 and above percent of savings.
Great. And last question, Simon, in terms of the demo that you did, so how much cloud experience would one person need to use Stacksmith?
Yeah, this is a great question. I think Stacksmith is most applicable for folks who have a little bit of experience on one of the cloud platforms. There's certainly folks we've seen who are coming from 100% on-premise, running their own data centers, are very familiar with some of the sort of data center management solutions. But I would say the right time to be thinking about Stacksmith is, maybe you have 1 or 2 projects already running on a cloud like AWS. You have some operating familiarity with the managed services, the billing, reasonably comfortable with the right security posture to meet your business needs, and you're now looking to roll out sort of access to the cloud to more groups, more teams, and more applications. Stacksmith obviously encapsulates a lot of knowledge that Bitnami itself has learned from working with each of the big cloud providers, Amazon, Google, Microsoft, VMware, Oracle. So sometimes we end up offering an advisory role, where folks are looking to solve particular problems on a cloud platform. We've often come across that problem elsewhere and can advise folks on the right way to go. Obviously, our focus is on applications, so it's not a general purpose kind of infrastructure advisory service, but because we've worked with lots of folks with lots of different types of application workloads, we can sometimes help.